Mr. Taru, back again. We're going to start discussing in statistics about how to collect or create or just get some data to actually analyze. We've been making pie charts and histograms and dot plots and stem plots and pick a graph. But we've been doing all this analysis of data, but have never discussed yet, have not yet discussed how this data comes about. How do we collect it? How do we create it through experiments? And I always talk to my kids about saving money in high school as teenagers for retirement because, well, you take that compound interest and you let it roll 30, 40, 50 years. Well, not 30, but if your retirement age is 65, you start saving when you're 16, you got almost 50 years for compound interest to roll up. You can actually have a pretty nice retirement and not have to stress about it too much. So I end up, for my birthday, I got a $100 bill t-shirt, so Funny Shirt Friday. Anyway, that's why I'm wearing this shirt. Okay, two ways of collecting data, two basic ways of collecting data. There's the observational study, where you observe individuals and measurements, but you are not imposing a treatment. Key phrase right here. So let's take the scenario of, again, talking about smoking and causing lung cancer. You can't take 1,000 people and randomly assign them into two groups where one group just is forced to smoke, the other group is prevented from smoking, and oh, by the way, not only is that already unethical, but you're going to have to all eat the same foods, live in the same houses, do the same job, exercise the same. Every facet of your life is going to be identical except for, oh, by the way, you 500 smoke and you don't. So in situations where it's impossible to run an experiment, or just isn't necessary, you're looking at an observational study, any scenario where you're not imposing a treatment. Now, what if you do impose a treatment? Well, then you're setting up an experiment. You impose a treatment on individuals or subjects, if they're humans, in order to observe their responses. Maybe you want to find out if a new cholesterol drug helps to lower cholesterol better than an old drug. Okay, take some people with high cholesterol, randomly assign them to two groups. We'll talk about how to do that later. And one group gets the old drug, the control, not a placebo like sugar pill, because high cholesterol could be very bad for your health. So maybe an old drug, and then the treatment group gets a new drug, and then you will later discuss how you compare those numbers to see if the new drug was truly effective. So any scenario where you're imposing a treatment would be an experiment. And experiments are the easiest way to prove cause and effect. Observational studies alone supposedly cannot prove cause and effect. I'm sure there's some scenario where somebody might be able to argue that a tiny bit. But cause and effect, and especially in life, is a very, very complicated and difficult thing to prove. You need to have a strong correlation or association. You need to have that association be consistent. We talked about with smoking about how it doesn't matter what country you're in, the more you smoke, the more chance you have of getting lung cancer. That the more explanatory variable, the stronger the response, that the cause precedes the effect, and that it's plausible. There's 5 key things to look for to show evidence for causation. And observations alone are basically not appropriate for proving cause and effect. A well-done sample will produce a group of individuals that will unbiasedly represent the entire population, the entire group of individuals we want information about. So if I wanted a survey at the school about how they feel about the teachers here, well, then I could just go down to guidance. I could get a list of all the students and randomly just pull numbers out of a hat and say, go randomly choose 50 students. So the population will be all the students at this school. If I only wanted to survey the seniors, then same thing, go down and get a list of all the seniors, randomly select maybe 100 of them, or 50, or who knows, whatever you feel like is appropriate. And the population would be just the seniors of this particular high school. So the population, by definition, is all of the individuals, but not like everybody in the world. It's everybody that, or everything that you want to learn about or represent in your experiment or in your observational study or your survey. If I do a survey of just my school about a topic, it could not therefore be then sort of imposed or summarized or inferenced for the entire county or state. Not if I just pulled students from my own school. So the population is the entire group of individuals we want information about. And a sample would need to represent that particular population you are trying to learn about. So if I want an opinion about just the seniors in our school, I'll randomly select just some seniors as an example. Okay, moving on. No. All right. Sampling involves part of a population to learn about the whole population, very often the best option. Let's go back to that survey in the entire school. Would I want to actually attempt to contact all 400 students that come to the school? That would be very time-consuming and unnecessary. I could just sample about 100 and get a very good idea about what the entire school feels about whatever I'm talking about. If I want to see what new cholesterol drug works better, or if a new cholesterol drug works better than an old cholesterol drug, I can't run an experiment on every single person that has high cholesterol. No, I would just go take a random sampling of people with high cholesterol. If, and think of like your country or your state, probably just a country government, wanting to run a census. How hard it is to contact everybody or everything in an entire population. So we normally just work with sampling and then try and inference the results from the sample to the entire population. The definition of inference is using a sample's results to make a conclusion about the entire population. We're not really doing that step yet. We're just collecting numbers, so I'm going to leave that vocab, this word there at that. A census attempts to contact every individual in a population. These are very expensive, very time-consuming, and very, very often not possible. And also, if you're trying to work with every subject or unit in an entire population, you will very quickly be overwhelmed by a mass of data, which will actually probably lead to more errors than just you would get from a sample. Okay, now we're going to talk about two sampling methods, and I don't think I'm going to have an issue with time, but I'm definitely having an issue with space. This video is going to be a multi-part video so that I can get all these sampling and experimental designs set up for you. Today is just sampling. Voluntary response. Sampling consists of people who choose themselves to be in the general survey. Think of radio call-in surveys, TV or internet surveys. These are most certainly negatively biased since we find it easier to complain than to compliment, even about ourselves. With my students, if I ask them what they like or dislike about themselves and give them just a short period of time to come up with some answers, maybe a minute or less even, the list of complaints even about themselves would grow very quickly, especially compared to what they were going to say they like about themselves. Just, when we're unhappy, we complain, we voice out, and not often enough compliment people or point out what things are good. If you're happy, you're kind of content and satisfied and just sort of, chill. So all these, go to the internet and click on what do you think, what you feel about, or hey, this is some kind of TV, maybe I'm conservative, maybe I'm liberal, and this is the show. Hey, why don't you get on the internet and give us an opinion about what you think is going on in politics or the economy or just whatever you feel like. The radio station, hey, call us in and tell us what you think about so-and-so that happened this weekend. All of those surveys are so common and they're almost always negatively biased. You get something to talk about, but there's no real validity behind those results. It's always going to be negatively biased. It's going to be more people complaining that are unhappy about what's going on, and therefore those individuals in the population will be overrepresented in a voluntary response, giving you what is known as a negatively biased survey. Woo! All right. No. Coming in on the left. Woo! All right. Last, not so great sampling method that we have in Intro to Statistics. That's convenience sampling. Convenience sampling is surveying those people who are easiest to reach, close by. You're not really doing any real hard work to get to these people. It's not a random selection. You're not trying to contact them by phone or email. through some randomization process. You just, well, what did I talk about? Interviewing shoppers just by going to the mall and talking to whoever walks by. This may be okay if you want to report the habits for the shoppers of that mall, but could not be applied to all shoppers. Let's say that you do have a shopping mall or you do have a store and you want to find out how you could improve that store. Well, if all you do is stand at your door and go, "Hey, are you happy?" Well, you certainly will get some negative comments. And again, you're trying to randomly select these people as they come in, or maybe you're just, well, actually no, you're just standing at the door and they just happen to walk in. "Hey, you like our store? You like what we're doing?" Well, wouldn't the people coming to the store already be happy with what you're doing? You might get a false hope that what you're doing, or a false conclusion that what you're doing, the way your store is set up, the prices, whatever, that they're all fine. But what about all those people that are not coming to your store? Like, if you find out from your shoppers if you're doing well or not doing well, certainly it probably has some validity, but if you really want to pull in a lot more business, why not find out what all those people not coming to your store? Why aren't they coming? Are the prices too high? Is it not set up well? I'm just one example, of course, but convenience sampling is just kind of chilling out. Whoever walks by, you kind of just survey them and see what's going on. That's not a good sampling technique. The convenience sampling and the voluntary response, they take little to work for the collector of the data, but you will not get results that are very useful or just not useful at all. Again, with the voluntary response, you could have negative bias. With the convenience sampling, it'll be nearly impossible for you to get a sample that truly represents the population that you would like to learn about. So you do not want to do these type of sampling techniques. We have to teach them, because if you don't know how to do things wrong, you might not understand what's good about what is right. So let's get this erased. Give me some time to copy a new set of notes up here. Of course, all you're going to do is hit play on the next video. Thank you for watching. I do greatly appreciate it. Hello, Mr. Tarub. Okay, we are doing part 2 of our sampling technique video, because we're going to start collecting data so that we don't have to always have it always given to us by our textbooks. Okay, sampling techniques, part 2. The remedy for bias in sampling is to allow random and personal chance to do the sampling. And I do realize I never talked about bias in the previous set of notes, even though I had written it in there. Okay, so what is bias? Bias is like, maybe you could have it in a question. "Hey, given the fact that some expert says so-and-so, what's your opinion?" Or, "Wow, we just had a tragic loss. Some kid was actually shot by his brother when playing with a toy, or playing with a gun like it was a toy. And, well, based on that, what is your opinions of gun control?" Or, "Man, the economy's sucking right now. What's your opinion of the those in power, the president or the whatever, the government?" So, bias could come from, I want to find out, I'm a bakery company, and I want to find out, just how many people in the population still are baking at home. So I'm going to start calling people at 2 in the afternoon and say, "Hey, I'm doing a survey for so-and-so, do you still make cakes and pies at home?" Well, if you're calling during the day when maybe there's a lot more, house mothers or house dads, stay-at-home dads or stay-at-home moms, taking care of the family, they might have that time and inclination to do more baking than, say, those people that are not at home. If you only call, let's say, like at 2 in the afternoon, like I'm saying. So you can have bias coming from words, you can have, of your question, you can have bias coming from bad sampling technique in an experiment. You can have bias show up if maybe the experimenter knows who got the treatment, who got the control group, and just sort of interpreting some bias in those results. And you can have bias from just bad sampling. If I want to find out, again, about keeping with the school and the education thing, if I want to find out what the students' opinions here are at this school about the teachers, well, I'm teaching AP Stats, right? So I'm not going to just survey my students. First of all, they're honor students. the kids that I get are not a random selection of the school, and so they might hopefully feel that the teachers are maybe better at the school than the overall population because they don't represent the entire population. My students would even represent the honor students at my school because, again, it was not a random selection. They chose to take my class. Okay, so that's a discussion about bias. You're systematically you're systematically getting one type of response or answer over another. Probably not perfect definition there or wording. So good techniques of sampling. We just talked about voluntary response and convenience samplings. Neither one of those are very good. What are some good sampling techniques? The most common that we'll use in the textbook of Intro to Statistics is an simple SRS. Every individual has the same chance of being chosen, and that's a key characteristic, and not like the most important characteristics of an SRS. Kind of like saying, well, what's a square? Well, it has 4 sides. Okay, can you be a little bit more specific? Well, all 4 sides are equal. Well, a rhombus also has 4 equal sides. So you need to say it's 4 equal sides and all the angles are 90 degrees. Well, what's the deal with a simple random sample? Well, yes, every individual does have the same chance of being chosen, but the key characteristic of an SRS is every set of n individuals has the same chance of being chosen. So if I want to do a simple random sample of students here at school, if I want to do a simple random sample of 30, then every possible combination of 30 students, even if they're all freshmen, could be a possibility. Every group of n individuals has the same chance of being chosen. And an SRS is one type of probability sampling, sampling chosen by chance, not all good. Not all will give every individual the same chance of being chosen. What do I mean by every individual will not necessarily be the same chance of being chosen? Well, let me just keep talking about the school here. If I wanted to do a technique we're going to learn in just a second, actually, let me go ahead and skip ahead to that. No. Okay. I'm back. All right, copy these down. Okay, so what am I talking about here where every individual doesn't have the same chance or may not have the same chance of being chosen? Well, stratified random sample. Let me get to that back to that in a second. Stratified random samples are good for selecting from a large population or when you think different strata will yield different results. What you do with a stratified random sample is you divide the population into strata that are similar in some way that you think is important to the response variable. And that's why I'm going to go back to this whole idea of an example of an education, a school setting. You take an SRS from each of the strata and you combine that to make one full sample. So if I, again, wanted opinions of students at my school about how they feel about the teachers, I could take about, I think it's like 2,400 students here this year. You know, I could put those names in a hat and just pull out a random 100, and that would be an SRS. Every group of 100 students would have the same chance of being chosen. But our freshman class is much, much larger than our senior class, which is kind of a sad commentary. And plus, you know, as we mature and we get into higher level classes at the higher grades, our opinions may change about the teachers we have. So I think maybe grade level would influence how students would respond to that question, how do you feel about your teachers at your school? So I might do a stratified random sample. Well, the strata is already set up for me, the 4 grade levels, 9, 10, 11, and 12. And then the second step would be to take an SRS of each strata. So maybe I choose 50 freshmen, 50 sophomore, 50 juniors, and 50 seniors to get an even weight to all the classes. Well, if I do that, then the seniors will have a more likely chance of being chosen because I'm taking 50 out of a smaller pool of students than if it were talking about the freshman class, because that freshman class is larger, unfortunately. You know, people drop out or they don't graduate or they just move away. So the senior class being smaller, if I choose 50 out of each grade level for high school, each individual student would have a higher chance of being chosen. Now, I could also make it proportional. I could say, well, the smallest group is the seniors, so I'll take maybe a group of 40 out of that. The juniors is a little bit larger, maybe I'll take 50, and then 60 out of the sophomore class and 70 out of the freshman class. Or, I can make it proportional so that every individual still has the same chance of being chosen. I could if I wanted to. Now, the difference between a stratified random sample and an SRS is, with an SRS, if I choose 100 completely random students, they could potentially be all freshmen or all seniors or somewhere in between. Whereas a stratified random sample, even if I make it so that every student has the same chance of being chosen, I adjust the size of those strata to fit the size of that grade level, it would be impossible. If I take an SRS out of each grade level, it would be impossible for all of the kids to be 1 or 2 or even 3 grade levels. If I force a strata to be 4 of them, freshmen, sophomore, juniors, and seniors, and I combine an SRS out of each of those 4 strata to make one full sample, I would be forced and be guaranteed to have a few seniors, a few sophomores, juniors, and freshmen. I don't know why I went out of sequence there. Whereas a simple random sample, when you set a sample size, every selection of that particular n size will have the same chance of being chosen, and that's not the case with a stratified random sample. A stratified random sample can give good data about each strata, so I can find the opinions, how they vary between seniors, juniors, sophomores, and freshmen if I broke it back up into the strata when I analyze it, and the entire population. If individuals in each strata are less varied than the population as a whole, the stratified sample can give better information than an SRS of each size. If I put together strata, and I'm putting those strata together based on a variable that I think will be important to the overall response, then you would think that each group would be more alike in some way, and I can actually get results that are more sensitive. If there is a difference of opinion or a change in the population, it might be easier to see with a stratified random sample. However, most of the techniques we will learn in our textbook this year are only good for data collected with an SRS. So while we're learning different ways to collect data, we might not be able to work with all those different types of data. That's for more advanced statistics. Let me talk for a second about this idea of taking an SRS and the idea that we need to have randomization in our selection processes. I've been talking about how we could just put, numbers in a hat. You can also randomly generate numbers with your calculator, but if you randomly generate numbers with your calculator, in your summary statement or in your example of how to do, or your explanation of how to do your randomization process, you will not be able to use your repeat numbers, not if you're actually selecting real individuals. You can't use the same person in your survey twice. You'll also learn, and I'm not going to do it in this video, but how to use your random digit table in the back of the book. You're not given a random digit table when you take the AP exams, so that's good for a textbook and being able to grade your work and be able to look at the back of the book to check your randomization process. But we will be talking about how to use a random digit table as well. But we will generally be either randomly generating numbers with our calculator, but we're actually doing a selection process. We'll have to skip the repeat numbers, or when you're taking a standardized test like the AP exam, the best way of describing your random selection is just putting numbers or names into a hat and pulling them out. And then, unless you put the names back in the hat, which why would you would be prevented from ever selecting the same unit or subject twice. So we will be talking more about randomization in a later video. All right. And our last sampling technique that I'm going to get to in this video is called cluster sampling. This is often used for practical reasons. It sounds very, very close to stratified random sample. We divide the population into clusters. We randomly select some of these clusters, and then all individuals in each chosen cluster is going to be part of the overall sample. Now, with clustering, It sounds like you're doing a stratified random sample, but in a stratified random sample, you take an SRS out of each strata. With cluster sampling, maybe, let's stick with, again, the opinions of students and the teachers at their schools. Well, what if I want to talk about the entire county? Well, I could choose a particular class, or let's say I want to talk about the opinions of students taking AP statistics in the entire county that I work in. Well, instead of doing a random selection of students in each individual school, my clusters could actually be the schools and then go, okay, we've got, I don't know, 20 high schools in the county, and I'm going to randomly choose 3 of those 20 high schools. Okay, so whoever is in those 3 high schools taking AP statistics would then be part of the survey. Not taking an SRS of each group of stat kids in each individual school. So stratified random sample and clustering sounds similar, but once you set up those clusters, you don't take an SRS or a few individuals out of each cluster, you just grab the whole cluster and then put those together. So again, a bunch of high schools in the county, put them in a bag and shake them up and pull out maybe 3 or 4 or however many schools I feel like using, and within each of those schools I have a cluster of kids taking statistics. I could use their opinions to answer some kind of question or collect data and then impose or inference that about the entire those results into the entire county. Multistage sampling is probably best if you just look this up and look at an example on the internet. Multistage sampling is just when you do stratified random sample, but you just do it multiple stages. I am out of time. Hello, Mr. Tarou. Might want to pause and copy this page of notes. Okay, so we just got done talking about the difference between observational studies and experiments, how to that we're going to start collecting data instead of just being given all this information to make graphs and pie charts and histograms and so on and so on. We talked about 2 bad ways of collecting data. That would be voluntary response settings, where you just pose a question in the entire population and let whoever wants to respond, like on TV, or on the internet or call-in surveys. We also talked about convenience sampling, which is also not a good way to collect data through a sample, and then did some proper techniques like simple random sample, stratified random sample, cluster sampling, and multi-stage sampling. Well, now I want to give you some cautions about these sample surveys that we're attempting to do to collect data. This idea of undercoverage, which occurs when some groups in the population are left out of the process of choosing a sample. Nowadays, where I live, a lot of people are starting to abandon their landlines, their hard landlines, for the use of the cell phones exclusively. So if I want to do a phone survey, and all I do is pick up a phone book and start calling phone numbers, then I'm undercoveraging the people that only use cell phones. Now, if the people that use cell phones are the same as the people that use just landlines, then that really may not cause a problem with my survey. But if there's a difference between those populations of people that tend to use cell phones, tend to be younger and more mobile than those that use exclusively landlines, or both cell phone and landlines, then that undercoverage may cause my sample to be biased because I'm leaving out a part of the population that would give a different response to my question, if that's pertinent. Because, you know, we are trying to learn about a part of a population with our sample, and if that difference is not important, then it won't be. But if there is a difference, if it is important to your survey, then that could be undercoverage. That would be a problem. Non-response occurs when individuals chosen for the sample can't be contacted or refuse to cooperate. Though we voluntarily choose to take part in a sample or a survey, this is not the same as voluntary response because we were contacted individually. No one can force us to answer questions in a sample or a survey. No one can force us to be in an experiment, not that we're discussing experiments at the moment. So there's always this idea of voluntarily being a part of whatever this survey or sample is, if you're contacted, of course, to be in a survey yourself. This is not the same as voluntary response. Remember, voluntary response is the newspaper saying write in, or write your congressman, or the TV personality going, hey, get online and vote on our online poll to give us your opinions. where they just blanket the entire population with one request for responses. That's voluntary response. We find it much easier to complain, unfortunately, than it is to compliment. If we're happy and content, we don't make a lot of noise. So voluntary response settings generally tend to be negatively biased, as talked about in the last video. Non-response is you get contacted individually, and for some reason you refuse. If you can identify a part of the population, you as a statistician, if you can identify a part of the population that has a much higher non-response rate, you can resample just that part of the population to try and fill in the gap. If you're doing a sample survey and you notice that large businesses tend to return your requests or answer your questions less often than small business, then you could do a small SRS of just large businesses to try and fill in that gap in your data from all the non-response. If you're sampling people in different regions like rural areas in the country, suburban areas, or big cities, if you notice that you want a sample that represents all three of those groups, and you notice a lot of people in the city say, hey, go buzz off, then that non-response, that high non-response in just the city areas would cause an issue with your sample and cause it possibly to be biased and not represent the population. So you could do a small SRS of just the large city people, dwellers, to try and pull in some more of those responses to fill in the gaps. So there are ways to sometimes deal with non-response. And then other times, there's always going to be non-response in every sample survey. It's just, something we have to deal with, and, it can never be removed completely. So undercoverage, you leave people out. Non-response, those people are choosing to not respond. That's always going to happen, but if there is an area of your population, an area of your sample that has a much, much higher non-response rate, you are allowed to go back and do a small SRS to try and fill in that gap with just that part of the population. Woo! No. Okie dokie. I talked about this in my last video a little bit, but you can have bias in a survey from a poorly designed survey. If I want to see what percent of people at home bake, and I just call people at home during the daytime hours, maybe I get a higher proportion of people saying they bake, as opposed to if I called in the morning, in the afternoon, and late evening, possibly catching more people that work in the early morning and the late evening. So I can have bias in response in my survey, my sample, from a poorly designed sample. I can have bias from behavior of the interviewer, embarrassment about the true answer, so they lie, race or sex of the interviewer, or faulty memory about the long past events. If somebody comes to my door, that is a minority, and starts asking me racially sensitive questions, I might be embarrassed or not want to answer honestly about those questions. If some nuns and priests come through the neighborhood and they're finding out they're doing some kind of survey about their church and religion, I might be a little bit more pressured to say something positive about religion because these people are to be respectful because they're priests or nuns. If you come to me and you ask about whether I do drugs or drink a lot, those might not be questions that I want to answer someone face to face with, so I'd be embarrassed. So I might lie and underestimate or just say no, I don't drink, or no, I don't do any drugs, or if you embarrass somebody, you're not going to get an honest answer out of them face to face unless something's set up to allow them to sort of answer anonymously about questions that may be embarrassing. You can have wording bias. When the question includes leading information, making one response more likely. Again, if I said, some expert says blah, 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 how do you feel about it? Well, you might be more inclined to agree with the expert's opinion that I gave you even before I started asking the question. So your wording bias can be an issue and give you faulty responses. There was I don't remember if it was in my book or something I read online, but there was a scenario where they were testing whether or not people preferred Coke or Pepsi. Well, that's kind of not really, that's still a sample survey, where they gave them, they said, okay, here's cup A, here's cup B, taste them and tell us which one you prefer. Well, they did not randomize what order people drank the sodas, and so it became biased simply because they more often chose the last taste they had in their mouth, or something like that, where they didn't randomize the order in which the soda was drank, so the results came out to be faulty. So that was bias. That was not from response bias. It was not from wording of the question. It was just simply no randomization in the process of the sample. And then we have this idea of inference. This is a huge concept. And inferencing is what statistics is all about. We take small samples, we analyze that sample, we draw conclusions, and then we sort of inference that, or make a conclusion about the entire population based on what we saw in the sample. So an inference of the population is making conclusions about the population from a sample. These samples are only estimates and have variations in their results. If 40% of the people in a local area shop at a certain grocery store, if I go ask 100 people, hey, do you shop at store X? You're not going to get exactly 40%. You're going to get around 40% because you're only sampling a small portion of the population. And not quite a survey, but even if you're just flipping a coin, you are going to probably not get the same results twice. This variability is what makes sampling distributions whose mean is sample mean or proportion, like when you flip a coin. Let's talk about flipping a coin for a second. You know, if a coin is fair, it's perfectly balanced, you're going to get heads in the long run 50% of the time. Well, if you flip a coin twice, it's not unlikely that you would get heads 2 times in a row, or 100% of the time. That's certainly not 50-50. Even if you flip a coin 50 times, you're not going to get an exactly 25 heads and 25 tails. You're going to get around 50% heads and tails. That variability is what makes sampling distribution, something we'll talk a lot more about later. So the mean of your sample, or the mean proportion, this would be like you flipping a coin 20 times and recording the percent of times you got heads, is, if unbiased, be equal to the population mean, sample mean, population mean, sample proportion, population proportion, if the sample is unbiased. So what that means is, if 40% of people in a certain local area shop at a store and you survey 100 people, you are not going to get exactly 40%. Well, you could, but it's unlikely. However, if you repeated that sampling, which is not necessarily a good idea in statistics, but as far as the idea of sampling distributions goes, if you were to continually sample unbiasedly 100 people in that area over and over and over and over and over again, and then take your results and make a histogram out of it, it will be centered around the 0.4. If 40% of the population, I should be pointing to the P. If 40% of the population shop at that store, then your sample results will center around 0.4 if it is unbiased. Okay? You flip a coin. If you flip a coin 20 times, you are not going to get heads 50% of the time, every single time. But if you flip that coin 20 times, record the percent of heads. Flip the coin 20 times, record the percent of heads. Flip the coin 20 times, record the percent of heads, and so on, and repeat that process many, 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 many times, and then make a histogram out of all those proportions that you observed out of the 20 flips. That sampling distribution will center around the true 0.5 if the coin is indeed fair. Okay, one more screen and we're done for this morning. Woo! Alright, last 2 statements. You're going to learn a lot more about these 2 statements as we go through the year, but as an introductory statement, larger samples have less variability and thus are more accurate. But it is possible for a survey or an experiment to actually be too accurate. If you're doing quality control at the end of an assembly line, if you do such a large sample that, let's say we're filling soda bottles. If you take such a large sample that you can tell that the soda bottles are being filled, let's say by, if it's off by more than ½ an ounce, and you stop the lines and you go, well, all right, okay, something's wrong with the machine, we're under or overfilling the bottles by ½ ounce. Stop the presses and change and make some adjustments. Well, if the boss goes, I can only make adjustments on 1 ounce increments, then you've made a test that's too sensitive. You're telling them that it's off by ½ ounce, but they can't, it has no real life application. Adjustment can't be made that small. I'm sure it probably could be, but the point is you can reduce the variability to such a degree that you get statistically significant results. Not that you quite know what that means yet, but you can, put your hands up and go, oh, something's weird, something's changing, and yet there has no real life application. It's too sensitive. And as long as the population is at least 10 times greater than the sample size, you'll be using that phrase a lot this year, it is only the size of the sample that determines the variability of that sample. So I'm recording these videos in Florida. If I take a sample of 500 voters and say, okay, in Florida, make a conclusion. If I take a sample of 500 people for the entire United States and draw a conclusion, those two samples have the same variability because they both have a sample size of 500, even though the state of Florida as a population is much, much smaller than the entire U.S. So, if the populations are greater than 10 times the sample size, it is only the size of the sample that determines the variability of the sample. You'll notice that when you look at all your standard deviation formulas for all the different types of variables we're going to learn, but that is a much later and a much longer discussion. Woo! Mr. True! Thank you for watching these videos. I'm hoping they're helping. Go do your homework, read your book.